life-saving equipment. It's the difference between lives lost and saved, between property destroyed and property protected. Which is why at Ceasefire, we don't just assemble our products, we engineer them to perfection, just so they perform at full potential when they are most required to. Extinguisher body manufacturing, valve manufacturing, assembly and quality tests. Every stage of the manufacturing process adheres to stringent and precise guidelines to create the country's most trusted fire safety products. Let's have a detailed look at them all. The making of an extinguisher starts with the manufacturing of the extinguisher body, a process that involves procuring the right quality of steel, processing it, cutting it to size, and preparing it for the later stages. To begin the process of manufacturing the extinguisher body, a company needs to procure quality steel, one of the most important components of efficient firefighting equipment. Ceasefire's IS 513 compliant cold-rolled, cold-annealed CRCA mild steel sheets are only bought from the finest companies. Our vendors include such giants as Tata Steel, SAIL and SR. The first step in extinguisher manufacturing involves cutting the CRCA sheets into predetermined sizes based on the size of the shell to be created. A blanking machine is brought in to execute this process smoothly. Once the blank sheets are cut to size, they are further cut into circles. This helps in getting rid of unwanted material. It also allows for a more efficient deep drawing process. At Ceasefire, we never convert the CRCA circles into tall shells in just one draw, because doing this will cause the shell to develop wrinkles and cracks. These cracks can render an extinguisher useless in no time. Our drawing process involves 3 stages. The first 2 draws use 150-ton hydraulic presses. The final draw uses a more powerful 200-ton press. The second drawing stage uses an entirely different set of dies to achieve the desired diameter of the shells. The third drawing stage produces the final shell diameters. The base of the extinguisher is drawn separately in just one stage, as the height of the base is relatively lower than that of the rest of the cylinder. Once the drawing process is completed, it is then time for the trimming of the cylinder. As the name suggests, this process trims the excess length of the shells and bases to get the desired heights. After the shells have been trimmed, base rings are created using another deep drawing process. Upon creating the base rings, holes are punched through the center of the shell. At a later stage, neck rings are welded into these holes. Once the punching process is complete, a beveled edge is then used to help foot rings fit properly onto the base. A lathe machine executes this process. Once the foot rings have been chamfered, the welding process begins. We bring in a metal inert gas (MIG) machine for this procedure. As welding is prone to generate heat in excess of 1000 degrees centigrade, our MIGs use ACM, a mixture of argon and carbon dioxide gases in the ratio of 80:20. ACM, being an inert gas, keeps the container from burning. Post-welding, an automatic numbering machine engraves the brand name, capacity, month and year of manufacture on every container. Post-welding, all containers are then subjected to a hydrostatic pressure test at a minimum pressure of 30 kgf per centimeter square for at least 2 minutes. This test checks the pressure withstanding capacity of containers. After the hydrostatic pressure test, acid and alkali-based chemicals are used to treat the outer body and insides of every container. This process cleans the container by getting rid of oil and rust. A coating of zinc phosphate also creates the ideal surface for a more durable powder coat. Degreasing, water rinsing, de-rusting, water rinsing, activation, zinc phosphating, water rinsing and passivation. Upon completion of the 8-tank process, the containers are then powder coated. Here, the powder is charged with a positive current, whereas the container to be coated holds a negative current. As a result of this, the positively charged powder gets temporarily deposited onto the container's surface. Immediately after powder coating, the container is baked in an oven at an average temperature of 180 degrees centigrade for 15 minutes. This causes the powder particles to melt and create a durable coat on the container. Once the containers are made to perfection, the process of valve manufacturing begins. From cutting brass rods to forging and polishing them, this process is solely responsible for manufacturing the all-important valves in an extinguisher. A power saw cuts brass rods into long pieces to create valves. The cut-up pieces are melted in an induction furnace at a temperature of 950 degrees Celsius. The heated brass piece is then forged using a 200-ton mechanical press die. The brass piece acquires the outer dimensions of the valve. The extra brass, which flows out of a die in the forging process, is removed with the help of another die mounted on a 30-ton capacity press. 6 different operations are performed on a computerized numeric control (CNC) machine simultaneously. A nozzle and pressure gauge bore is drilled onto an automat. Bores for the handle, trigger and a special bypass bore for the pressure gauge are then drilled. On completion of the drilling process, the valve body is exposed to a 3-minute blast of aluminum oxide granules. This creates a rough texture on the valve body, allowing it to obtain a matte finish look of nickel chrome coating. Once the valve body has been manufactured, the process of valve assembly begins. The entire valve consists of a valve body, a plunger, a spring, a dip tube, a holder, O-rings and a pressure gauge. During valve assembly, all these parts are carefully put together to create a fully functional leak-proof valve. Once the extinguisher body and valves are ready, they are assembled to create near-final extinguishers. At this stage, the extinguisher is filled with powder and propellant and valves fitted onto the body. All our powder filling machines work on the vacuum principle. A vacuum sucks powder into the hopper. This powder is then released into the attached container. After powder filling, an assembled valve is inserted into the neck ring and tightened using a torque spanner. Once the valve has been inserted and tightened, 99.99% pure nitrogen with helium is filled into the container. Powder-based extinguishers are charged at 15 kilograms, whereas water, foam and clean agent extinguishers are charged at 10.5 kilograms. All pressurized extinguishers are then tested in water by placing inverted glass on top of their valves. This is the most natural, accurate and scientific way of testing leakages. After the water leakage test, a helium-sensitive machine then further tests the extinguisher for leakage. If extinguishers are found leaking at rates whereby their pressure would fall by more than 2 kilograms towards the end of the 5-year warranty period, they are immediately rejected. After checking for leakages, the brand name and capacity of the extinguisher is pad printed onto them. The pad printing process is followed by the crimping process. Here, hose pipes with a minimum bursting strength of 50 kilograms are accurately crimped, that is, fused together with their nuts and nozzles. This is to ensure that all extinguishers meet the ceasefire seal of approval before they are dispatched. To ensure that all extinguishers are in perfect working condition, they are put through a battery of batch tests. These tests examine the extinguishers for leaks, bursts, corrosion, and any other damage that can cause them to fail. Even if one extinguisher is found faulty, the entire batch is immediately discarded. The test is conducted to determine the extinguisher's burst capacity. To pass the test, the extinguisher should not burst at 2.7 times maximum service pressure or 55 bar, whichever is greater. Any burst should not cause the extinguisher to fragment. Here, the extinguisher's body is made to sustain 5,000 pressure cycles from 0 to its test pressure. To pass the test, the extinguisher should not rupture. To ensure high quality of gauges, the extinguisher's gauges are tested for 500 cycles to ensure that they are showing the right pressure. The extinguisher is filled with 90% water, pressurized and dropped from a height of 3 meters, first horizontally and then vertically. Extinguishers that leak after this test are immediately discarded. This test examines the strength of extinguishers. Tall extinguishers are made to stand up straight and then crushed for 30 to 60 seconds. Once crushed, the body is tested for leaks and cracks by filling it with water. One extinguisher from each batch is manually discharged to ensure that the pressurization and release mechanism works to the desired standards. A charged extinguisher is held vertically and continuously dropped 500 times onto a hard surface. This tests the settlement of powder, which would otherwise take years to examine. This test examines the temperature range within which an extinguisher can operate normally. Extinguishers are tested in ovens and chillers for 24 hours at various diverse temperatures, ranging from positive to negative. At the end of 24 hours, if the extinguishers are functioning normally, they pass ceasefire's stringent quality demands. A 4 kilogram steel cylindrical hammer is dropped vertically on a fully charged extinguisher. The extinguisher must not release pressure in a potentially dangerous manner upon contact to pass the test. Extinguishers not meant for vehicles are subjected to a vibration test in each of their axes: horizontal, lateral and vertical. This test judges whether or not extinguishers can withstand vibrations suitably. A fully charged extinguisher is exposed to a salt spray for 24 hours. Following a drying period of 24 hours, the extinguisher is then washed carefully to remove salt deposits. At the end of the test, the body of the extinguisher must remain intact without any signs of corrosion. The release of the safety device, stopper, which is used to prevent the extinguisher from accidentally operating, requires a specific amount of force. The safety locking test ensures that every ceasefire extinguisher meets the desired standards. "500 grams of powder is made to flow in an apparatus consisting of 2 glass conical flasks. If the powder flows at an average rate of under 50 grams per second, at least 10 times, the extinguisher gets ceasefire's quality seal. Why do we do all this? Why do we put our products through the most stringent tests in the country? Because we understand one thing. When it comes to life-saving equipment, there is no room for error. We understand what our customers need most: the freedom to live their lives without fear.